Hello, everybody, and welcome to episode 10 of the Hot Path Show. We're in the double digits now, officially, of the Hot Path Show. My name is Johnny Turbo. By the way, newly minted purple belt in Brazilian Jiu-Jitsu, Johnny
wow.
Turbo. Oh, yeah.
Yeah, I saw it on Twitter. That's pretty cool.
Yeah. It's a little bit of a big deal in Brazilian Jiu-Jitsu. There's only 5 belt levels, so usually you're going to be at each belt level for a good couple years. So, yeah, very excited to get my purple belt. Not a lot of people who start Brazilian Jiu-Jitsu go on to get their blue belt, and an even lower percentage of people end up getting their purple belt. So,
Wow.
very very excited about that.
How many belts left at that point?
What's that?
How many belts are left at that point?
So after purple belt is brown belt, and then after brown is black.
Okay, you're 2 away from black.
But again, still could be, a number of years at purple belt before the brown belt, and then, another number of years after that to black. So, yeah. Anyways, this show is not about Brazilian Jiu-Jitsu. It is your weekly dose of Unity Dots propaganda.
Propaganda? Oh, really?
Exactly. But yeah,
Wait,
anyways.
that's not good. Then I'm spreading propaganda in that case.
Exactly, yeah, straight from the source. But so Danny, welcome into the Hot Path Show. We'll get a very excited episode today. How you doing?
I'm doing great. I mean, I'm excited to see what people have made. I wish I had made something myself, but I'm excited to see what other people have made.
Yeah. And so what Danny is hinting at is kind of the main topic of the show. What we're going to be discussing is I recently put up a Unity, the first Dots community challenge, where I basically tasked everybody to create the highest performing version of Conway's Game of Life that they could using Unity Dots and ECS. We had, I believe, a total of 21 submissions. I kind of asked everyone to do a little bit of a write-up about what they did to implement the highest performing version that they could. There was a whole bunch of interesting things that I learned from everyone's submissions. And so we're going to be talking a little bit about the submission that I had created, as well as the other submissions from the community. And a lot of the submissions from the community totally kicked the teeth in performance-wise compared to mine. So a lot of really cool stuff in there. So that'll be coming up later in the end of the show. But real quickly, before we start getting into some more just kind of regular topics for our show here today, do have a couple of miscellaneous announcements. Make sure that you wishlist Just Read the Instructions over on Steam. This is our other co-host Tobias's game, which is coming out on April 10th, so in just a little bit over a week here. It's a cooperative, basically first-person shooter type game made with Unity's Dots and a custom network stack. Really cool game. Again, it's called Just Read the Instructions, coming out on April 10th. And then on the episode of the Hot Path Show for that Friday, which I believe is the 12th of April, Tobias is going to be on talking about his game and some of the technical challenges that he had faced and how he kind of solved those things with Dots and ECS. So yeah, very much looking forward to that one. There should be a link down in the description of this video if you want to go to the Steam page to check that out. Also, just have a couple cool new assets here to share on the Unity Asset Store. So let me go ahead and share my screen and show you kind of what's going on here. So there is a new Dots asset. This is the Dots Traffic City. So this is basically all built with Unity Dots, and there's, you can kind of see the little animation playing here. So if you're kind of doing anything with cars and cities and having like crowds of people, then this is a great asset to look into. The developer of this asset did actually reach out to me and provided me with a code for it. So I haven't got a chance to experiment around with it, but let me know if you are interested in maybe seeing a review of this asset, for me to just kind of play around with it a little bit more and just kind of give my thoughts on the features overall and everything. But so this is a cool asset. I think there should be a link for this one down in the description as well. Just on the Unity Asset Store. It's called Dots Traffic City. And then another one that I wanted to showcase was an asset created by Chiro, a former Unity employee. And he created this cool asset. This one is like not necessarily an ECS, Dots ECS specific one. It's called Black Box prefab encapsulation controls overrides. And so basically the idea here is if you have a prefab and you have this whole kind of like nested hierarchy like this, what you can do is you can just go onto the prefab and then you add this black box components. And then what happens is this kind of like encapsulates this prefab and treats it as just like one single object. So you'll see now, yeah, back in the scene here, you'll see that this prefab, it previously had this kind of nested hierarchy, but now it's just like one single object. And so you can kind of, select that single object, by clicking it in the scene view, of course. And, you don't like end up like way deep in the hierarchy, like, selecting the, elbow joint or something like that. Like it just kind of selects the base root prefab. And then, because it's all kind of like encapsulated into one thing, you can actually expose some of the fields, which is what he's doing right here. So if there's any like, specific things that you need to edit, you can kind of expose those through this kind of black boxing here, so that again, it's kind of all treated as just that one single object, and you can just edit the specific things that you need to. So, cool little helper tool. Of course, this is, just works with regular Unity game objects. And, when we're dealing with authoring prefabs in the, in ECS, of course, it's the exact same as interacting with prefabs in regular Unity. So this is, completely ECS compatible as well. So yeah, definitely another cool asset to check out. Again, I will have a link to this down in the description below.
I mean, that asset very much goes in line with the way that I generally tend to like offer ECS objects, because the thing about entities generally is that you're not supposed to use any sort of inheritance at all. However, there is one place that inheritance generally does make sense, and that's for things like, let's say you had a game like World of Warcraft and you were building out your orcs and elves and so on, all their attack patterns, all their different styles. You would still want a base enemy sort of setup, and then you can extend something to be an elf. The way that you would do that in an ECS sort of way is by doing that in the data itself. So elf is actually just a base enemy that has some additional data that makes it something more, something that has also elf attacks and some stealth, stuff like that. Or overrides existing properties, and I do think that Zero's asset does make that setup easier, because you can have one authoring object, and that authoring object is then spawned into what becomes the ECS entity, and that can have many different variations, but it's still just going to be the specific change that you want to make.
Right.
So,
yeah.
I think the asset is really fucking great.
Yeah.
And it actually works well for entities. It's just not the entity itself.
Right. Yeah, exactly. So yeah, what you're saying is basically just kind of like figuring ways where you can kind of, share the most kind of, behavior between multiple things, and just kind of, tweak things as you need to, right?
Yeah. You have your base enemy, and then you have your orc, and you have your elf, and they can be two separate prefab variants, and this makes it easy to do that.
Sweet. Sounds great to me. So yeah, again, go ahead and check out the black box assets over on the Unity Asset Store, as well as the Dots Traffic City if you're interested in either of those. And then, yeah, so just wanted to remind you that you can still support us over on Patreon at patreon.com/turbomakesgames, where we'll have a lot of cool bonuses available to you. So over there, basically all supporters get access to a monthly bonus video. And I just put up one, which was just kind of like a vlog/recap of my GDC experience, where I was just kind of like showing a bunch of like pictures and videos, and like just kind of talking about, everything that I did throughout the week. So I had, a really fun, fantastic time at GDC. And so, yeah, just kind of, put together a little video, just kind of going over everything that I did over there. So go ahead and check that out. Also, for the people at the L1 cash support level and up, they do have access to some behind the scenes episodes. And so I've recently just put up an episode going over kind of like the software that I use on my computer, and just kind of like how I have things set up from a software perspective. Because I did a previous one where I showed kind of my whole hardware setup. So this one I'm kind of going a little bit more into the software side of things, showcasing some cool tools I use and everything like that. So that should be a fun one. And then also people at the L1 cache support level have access to a monthly Q&A that I do. So I put up a request for questions up over on the Patreon. So if you do have any kind of questions for me, feel free to drop those on that post over there. If we don't get a whole lot of questions, I'll probably just end up ranting about some random topic or something like that, kind of mixed in with that as well. But yeah, go ahead and check that out. And if you do have any questions, feel free to put those in as soon as possible, because I'm probably going to be recording that over the weekend here and posting it shortly after that. Okay, so anyways, we can go ahead and get into some of our kind of regular topics here. So this is going to be getting into the prefetch, which is our warm-up topic of the week. So this one, I wanted to talk about something a little bit interesting, and this is the whole thing with the Apple M series vulnerabilities that were recently discovered. So of course, many people know that Apple has kind of created their own CPU architecture called these like the M chips. So there's the M1, M2, and M3. And then some security researchers recently discovered a vulnerability with these Apple M series chips where you can basically get any information that you want to on a particular machine, as far as I understand it. It is super interesting how this vulnerability kind of works. I want to just real quickly share a video from Casey Muratori, who
security
basically just kind
researchers
of
disclosed
put up a whole video kind of going over this vulnerability, but it's not just about the vulnerability. It kind of goes into a lot of how kind of like hardware prefetching and just the cache and everything works. So it's a really interesting video to kind of like have a better understanding about what the CPU does to do its own kind of hardware level caching. And I think us as developers, it's kind of a good idea to have a really strong base about how this works, because this is again what a lot of the ECS and DOTS optimizations are based around, is cache and memory efficiency. So if we can kind of understand this as developers, we can most kind of optimize our program for these kind of accesses. So Danny, have you, it sounded like you hadn't gotten a chance to check out this video, but do you just kind of have like any thoughts in general about, things along the lines of optimizing for cache performance before we start getting into kind of a little bit more specifics about this vulnerability that was discovered?
While I haven't watched the video, at the very least, the fetching instruction, prefetch instruction, is something we use quite often. For instance, if you go and look at Entity Query Enumerator, which happens to be the main power horse behind System API Query, you can actually see there is like a burst intrinsic saying, hey, we expect this to be prefetched in order to optimize getting that data in earlier. Yeah, I haven't seen this particular video, but we do use the prefetch instruction quite a lot.
Nice. Yeah. And then so the again, this video is really great. I would highly recommend it. He actually, I think he had put a video out like the day before on this, and then he had like tweeted out that he got like one small thing wrong, and then he just like completely re-recorded this like hour-long video with the correct information. So yeah, shout out to Casey. And yeah, I mean, all of Casey's stuff is just like so incredibly valuable to me. Like, if I can make a video that's like 1/10 as valuable as one of Casey's videos, like I'm happy with that. But yeah, so anyways, kind of like going into a little bit about this video and this kind of vulnerability that was discovered. The whole kind of idea is, of course, there's multiple ways that you can do caching. One way that he just kind of quickly mentions at the beginning is by doing kind of like a traditional software caching, where that's where you're kind of doing that as a developer in your program, where you're kind of storing data in like an array or somewhere that's like very easily accessible to you. Whereas hardware prefetching and caching, basically what this does is, when your program is executing on the CPU starts to kind of like recognize patterns about memory access and kind of where it's actually accessing data from. And then what it does is, based off of those patterns, it kind of makes some determinations to say, hey, if you're kind of like iterating an array, let's kind of like prefetch and like pre-cache the next elements of the array and like store those so those are ready to go. So you don't have to like, constantly be going out to main memory, which ends up taking more CPU cycles than if you were to just, get it straight from the, L1 or L2 cache. So that's kind of like the main idea, is like having memory stored closer to the CPU that it thinks it needs. And so this can be, again, kind of done in a couple ways. One, common way is for just kind of like linear access of an array. If you're just kind of linearly going through an array, it'll get those kind of first couple elements and then the next couple, and so on. And then, there are other ways where, maybe if you're kind of like jumping in like 8 elements at a time, it kind of like knows to, get those, elements ahead of time, basically. So that's kind of like how it traditionally works. What's different about the Apple M series is something kind of interesting, that it has a DMP, which is called a data memory dependent prefetcher. So this is something that some newer CPUs have, where all the Apple M series have this DMP, and then also some of the newer Intel processors have a DMP solution as well. So basically, the difference of what this DMP does is, now instead of like just prefetching like data just kind of like in an array, it kind of does a little bit of analysis to detect that if that element that it's prefetching, quote, looks like a pointer, and then if it thinks that it's a pointer, then I believe, what from my understanding is what it does is it actually goes out to memory, or it looks at that kind of like memory, that pointer location, and then gets the actual data that pointer is pointing to. So it's kind of like, another step of optimization, where it's kind of, prefetching data that it thinks you're going to access because it thinks that it is a pointer. Now, this gets a little bit interesting because it's like, how do you tell that something is a pointer? I actually saw another video by a guy, the Primogen. He does a lot of kind of Twitch streaming and reacting to things of this nature. So he did a video basically talking about this whole Apple M series vulnerability, and he did this like hilarious bit where he was like, how do you tell if something looks like a pointer? He's like, if I was tasked with creating a program that said looks like a pointer, here's what I'd do. He opened up a text editor, and then he made a function called is looks like pointer or whatever, and then he put return true.
Yes. Yeah, no, that sounds about right.
Because a pointer is basically just, an index into memory, a number. So it is actually kind of interesting the way that they determine if something, quote, looks like a pointer. So the way that they do this is the kind of location that pointer is being held. Of course, that has its own memory address associated with it. And then if and that is kind of, like 8 bytes. So then it can kind of, that is 8 bytes. So then that kind of like is essentially the value that it's kind of being stored at that memory address. And then, so basically what it does is it actually just looks at those top first 4 bytes. And then it says if those top first 4 bytes matches the memory address that's being stored at, then they, like, from that information, they can basically tell that the data that potential thing there is pointing to is within the same 4 gigabyte range of that actual pointer. Because you figure, if you're in most programs, if you're like, allocating pointers, more than likely the data that you're going to be pointing to is going to be within kind of that 4 gigabyte range in memory. it's not going to be like somewhere kind of like way far out. Most of the data that you're allocating inside of an application is going to be, fairly close together. So that's kind of like the way that they do it. It's a little bit of an interesting trick where, again, they just look at those like first 4 bytes, and if it matches, where that data is being held, then they know that it's kind of within the, proper range. So that's kind of how they can tell that it looks like a pointer. And I thought that was just kind of like an interesting little trick that they did. So then, yeah, basically that's kind of how this DMP, the data memory dependent prefetcher, works. Again, go ahead and check out Casey's video. You'll see that he's actually, explaining this part right now where, yeah, they just kind of ignore the lower 4 bytes or, because that's just kind of like the, specific location inside that 4 gigabyte range, which you don't necessarily need to know. And then, yeah, again, it goes a little bit more in depth about how this DMP solution works. But then the whole kind of idea behind this vulnerability is that it kind of uses like a memory timing attacks. And these memory timing attacks have kind of been known about for some like a long period of time, like going back to kind of like the early days of computers and everything like that, where basically the idea is if you kind of request some bit of data and then it returns to you, slowly, then you can kind of think that, most likely that bit of data is stored outside of the cache. However, if it's something that's returned to you very quickly, then that bit of data, you can kind of know that it was already stored within the cache. And then if it was, if it could have been there from another process that had been kind of accessing that data. So, that, some other process on the machine is accessing that bit of data. So that can kind of give you a little bit of information about, what data other processes are actually accessing. Now, there have been, things in place because these kind of vulnerabilities have been known about. So to do kind of like, memory segmentation and things of that nature. However, with this new DMP, this kind of brings back some of those vulnerabilities, just kind of like the way that it is kind of like set up. And again, I would highly recommend going through this video from Casey. I believe I have a link to this down in the description as well, because he goes very in depth into how this works, and it's very like accessible too. You don't need to have like a whole lot of background knowledge about like security research or anything to follow along with the video. But yeah, it is just kind of like a good, interesting overview about how kind of, DMPs and prefetching works. And I think it can kind of give us a little bit of insight as developers as to kind of, how to optimize our programs for most efficient cache access. Now, Danny, that might be something that's a little bit more relevant to you and your job as opposed to, people who are just kind of interfacing with the Unity engine a little bit more directly. But yeah, I mean, how much, I guess, do you guys kind of like consider cache access? Otherwise, I mean, you kind of already mentioned that you take advantage of the prefetch command and all that. But yeah.
I mean, generally, we consider it as soon as we see it in a profile, and we profile quite often. At which point we can see, hey, do we actually need to squeeze more performance out of this specific part? And if we do, we can figure out, hey, this part here seems to be in need of a cache prefetch. That's for instance how we figured out the entity query enumerator prefetch, because that's a hot path. Iterating across a bunch of entities is a hot path, and so when running a profile over it, you quickly realize, hey, you actually need this instruction here at this point. But otherwise, we don't need to do it that often. It generally just comes down to a case-by-case basis and whatever your profiler tells you. And people should always be profiling quite often.
Yeah. I mean, that is a really great point. I mean, there's no need to necessarily need to make any crazy optimizations as far as performance goes. If it's something that isn't really like happening very often, you don't need to like get really crazy and do all kinds of DMP and cache optimizations. But again, I do think this is just kind of good background knowledge to have so that you kind of have some more tools in your tool belt. So, when you are profiling and you run into some of those issues, where you think it
100%.
is, something along the lines of like memory access is kind of really bottlenecking you, which is actually something kind of relevant to what we'll be talking about a little bit later in the show when it comes to the Conway's Game of Life and all that. But yeah, again, just kind of like, having some background knowledge available to you so that, when you do see this, that you actually can do something about it.
Yeah, prefetching is definitely one of those that is like a tool in your tool belt whenever you are stuck figuring out how can I actually optimize this specific thing. It's a classic, like anytime that you have anything that has to do with trying to optimize, the first thing you go for is the classic data structures and algorithms. But oftentimes it's actually the data structure that gives you more performance boost than just the algorithm. An algorithm can actually make it harder sometimes to get the true performance benefit. Just by simplifying something down to a linear array gets you there. But then what do you do when you already have a linear array that you're seeking across? Well, sometimes you need to pull out stuff like this, like the prefetch instruction. And it's good to know that it exists for you to reach. It doesn't mean that you have to learn it necessarily now. You just have to understand the cases where it is good to know about, so that you can go in, okay, now I'm incurring this performance problem, and it seems to be related to not being able to cache fast enough, or it seems to be related to not being able to access memory fast enough. Maybe prefetching works for this case, and then I can research how do I actually do this. And for the case of Unity, we have a burst intrinsic that you can put in to enable this.
Yeah, the burst intrinsics are definitely interesting. How often do you kind of use those in actual like project code that you're like creating a game or something like that? Like
not that often. In game code, not that often. In ECS entities code, we use it quite often. You can see it littered around the entity manager, especially the one called burst hints. We have something called a burst hint, which allows you to say, hey, this code is very likely to return true, or this is very unlikely.
Right. Yeah. I have seen that a bunch just as I was kind of been like digging around in the source code, and I'm like, was kind of like interested, like, oh, I wonder if this is like, something that would be useful for me to just kind of put in some places in my code to, again, kind of say, hint that this branch is, the likely scenario and all that. Although I was talking to Tobias about this, and he was kind of said he put a bunch of those burst intrinsics in kind of one of the kind of more hot path areas of his program, and he said it did not make any difference at all whatsoever. He's like, I would just assume that burst compiler is just kind of making the correct assumptions already.
The thing is, it kind of has to compound a lot before it actually makes a big difference, at least from my understanding. Where, like, because one of the things that it will figure out based on that is it will just basically put it into, what's the name? Clang is based on LLVM. So it will just put it into LLVM IR, and just hint to that, hey, this is something that you might be able to optimize for. At that point, it will figure out, can I take this loop and unroll, like wrap the loop in an if statement, and then either do it with it or without it. So we have two versions. Like if you have a big loop and inside it there's an if statement, sometimes it makes more sense to put that if state, that the compiler will realize it makes more sense to put the if statement outside the loop, and then check that condition and then run one or the other. It will find cases where it can do that, and sometimes the burst hinting will help it do stuff like it, and especially if you have a bunch of like nested fors or a bunch of ifs inside, it will be more easily able to do that. It doesn't mean that there will actually come any extra performance out of it. It just means that there's a chance that it might. Which is also the classic with any sort of LLVM style optimization.
Right. And then just to kind of close the loop on the like Apple M series vulnerabilities, this is still, something that was just discovered within the past few days here. So still kind of unclear about, what the impacts this will have and, how potential attackers could kind of take advantage of it. Again, this is something that security researchers had just kind of discovered on their own, and then, published from what I understand, a, very lengthy and in-depth paper on the whole scenario. So yeah, I think it's just going to be, take a little bit more research and experimentation to see, how easily one of these kind of attacker processes could be, where you can kind of do some of these memory timing attacks, to again take advantage of how that data memory dependent prefetcher is all set up and working and everything. So yeah, it's kind of unclear if some executable needs to be running on your computer, or if somebody could just kind of run this through some JavaScript, and you go to a bad link on a web page and then all of a sudden they have all your passwords and everything, or whatever. So still a little bit unclear, and from what I understand, this mostly just affects the M1 and M2 chips. But it's I guess on the M3 chip, there's an ability to maybe turn some things off to kind of mitigate the effects of this. So yeah, I guess maybe people can hack into your Apple Vision Pro now.
Oh no.
All right. Well, yeah, Danny, do you have any other final thoughts on that before we move on here?
Nope.
Sounds good to me. Do you have a cache hit for us? I forgot to ask you before.
A cache hit?
Yeah.
I don't think I do. It's a bummer.
Well, so I actually have an interesting comment that I got on a YouTube video recently that I think I could real quickly just bring this up. So let me see if I can just kind of open I'll just share the screen like this. So someone said, so this was in my Netcode for Entities big, complete course tutorial. So in there, when I was kind of setting up my project settings, I had IL2 CPP enabled. And then this user here, Saito853, says the reason for not using IL2 CPP yet is because the build time you can get pretty long during development. You usually have multiple iterations of the game to either fix minor bugs and errors or tweak different system changes. It's much better to just not enable IL2 CPP until you actually build a production ready version. So yeah, basically just kind of build with Mono, as you're developing, and then use IL2 CPP when you're ready kind of for that final production build.
Yeah, and I wouldn't even say only build with Mono. Also, there is a setting not a lot of people know about, which is you can also disable burst in builds, which is not... You know how you disable normally burst by going into jobs and then
inside
burst?
The editor. Yep.
Yeah, because that setting won't disable in builds. When you go build, it will still use burst. You actually have to find I think it's in player settings or something similar to that.
Right.
If you just search in the settings panel, you can search burst or disable burst. Then you will find it. That will actually disable burst also in builds, which means you can now have a fast, efficient way to build that will only take a minute or so for small game projects, which is very important when you're doing netcode. Because netcode, you have to sort of test if your multiplayer solution works for you, and make a player build. And so I generally recommend just disabling burst and disabling IL2 CPP, aka going to Mono, and in the future going to Core CLR when that is a possibility.
Oh yeah, very excited for that one.
Yeah.
But I thought this was a super interesting solution to it. I guess I didn't really put two and two together about IL2 CPP being kind of a cause of slower build times. Because one thing that I had noticed as I was kind of prototyping out the Netcode for Entities project, I wasn't using any the multiplayer play mode tools. So because this was a networked project, and if I wanted to test out 2 instances of it to make sure things that were actually synchronizing, I would have to create a new build of it. And then, even for me on this very simple, MOBA game project that doesn't have a whole lot of systems, doesn't have a whole lot of assets or anything like that, every single time I want to make a build, on clean builds, incremental builds, I mean, it was like at least 3 to 5 minutes every time. So that was quite annoying, going through all that. But I haven't actually done a timing difference on this particular project by using disabling IL2 CPP. So I'd be kind of curious to see how long projects take for just kind of regular builds as well as incremental builds where, again, it was kind of annoying because like I'd do a test and it was like something that wouldn't work. And then I would have to make just like, a small code change to fix that. And then it's like, boom, another 3 to 5 minutes waiting for a build. So, yeah.
No, I mean, it also makes sense that IL2CPP is so slow. It's IL2CPP, which means that it first has to become IL, which means that it's C# becomes IL through the Roslyn compiler, becomes IL2CPP. So now it's C++ code.
Right.
Which then
we probably
has to
should
run
have
through an actual compiler to turn into the final binary information. There's a lot to that.
Yeah.
Whereas if it was just, I mean, that's also the reason, by the way, why Burst is so slow, because it has to do IL becomes C# becomes IL becomes LLVM IR, then LLVM has to run to turn it into actual fast code, binary code, machine code. But if you have to do that for both IL2CPP and Burst, then it's just a very slow process. And Mono can just like read the IL directly anyways, which is why that's fast, but also runtime slow.
Yeah. And just for context, IL is intermediate language, so it basically means intermediate language to C++ is what that IL2CPP stands for. Yeah, so I thought that was an interesting comment, so just kind of wanted to share that here. Okay, so with that, actually I probably should have just kept sharing my screen here because we have another new Unity ECS version 1.2.
Already?
Full released is out already. It's out in the wild.
That was quick.
Yeah. So there has been some pre-release versions of ECS, which I have talked about in previous episodes of the Hot Path Show. And I believe I have these clipped out on the Clips channel of the Hot Path Show. You can just get to the Hot Path Show Clips YouTube channel, where I've kind of gone over some of these other pre-release versions. But yeah, the full 1.2.0 version is released. I haven't actually tried because I just saw this like yesterday, but now if you go to the package manager, this should show up as basically like the latest ECS version. And you don't need to like specify the proper like version number. Like you had to put package name and version number if you're doing a pre-release package. But this is the official package. It's available now. Not a whole lot of changes, just because there had been multiple pre-release versions, some experimental and pre-release versions available. So yeah, mostly it's just kind of like fixing out a couple of those little bugs that had been probably discovered during the pre-release phases. But we do see that there are some performance improvements in the local to world system, especially when processing entities with non-dirty hierarchies and no children. They did deprecate the entity manager.copy entities. I guess the copy entities, what this did is it was kind of like a way where you could like create a copy of a prefab instance, but it wouldn't remove that prefab tag. They basically said, we're not aware of any use cases of this function outside of the entities package itself. So now this is basically an internal only API, and they say basically just use entity manager.instantiate. And I suppose if you really wanted to retain the prefab tag, you can just add the prefab tag. Is my understanding of that correct?
Yeah, I think so. And I'm pretty sure there was a discussion internally also why we wanted to remove that one, because obviously we don't want to remove stuff willy-nilly from an already released version. And that I think this one was particularly concerning for a bunch of reasons. I can't remember, but there was like a whole discussion on why this one is so bad. Because I just remember that it was bad. Like it had a lot of like how do I say this? Like it was dependent on a very specific set of cases to happen, and for all of those to be true, for it to create something correct on the other end, and it was just badness in total. There's not really a good explanation other than that. It's just API that shouldn't have been there in the exposed in the first place.
Makes sense. Well, yeah. Hope nobody out there is using copy entities and relying their project on that. So
I mean, I'm sure we just made it. Okay, it does say we deprecated it, and I'm sure, knowing most users, they will just do something like, "Oh, this internal keyword is public anyways." I've seen so many cases where users just use internal as meaning spicy public.
Nice. Beta. And then, we have a couple fixes in here. Did highlight a couple of these because you see that there are some things related to the entities hierarchy window, which in my opinion is just completely broken. So any fixes and improvements to the entities hierarchy window are always welcome, because I do think that it is, kind of a nice feature to have, even though if it is a little bit redundant with the regular hierarchy and doesn't have all the features that the regular hierarchy does. But I think some improvements to their fixes are good. And then there's just kind of a couple other, little minor fixes and optimizations in here. So again, nothing too crazy. This is just kind of like the main stuff in the 1.2 release. The graphics and physics package both have some very minor changes as well, like, literally like 1 or 2 entries. And then the netcode actually doesn't have any changes for the full 1.2.0 version. Any final thoughts on version 1.2.0?
No. I mean, I'm just excited to see that we are releasing so soon after.
Yeah.
Already 2 releases this year.
Well, there's been, I think, a couple of the, what are you referring to, like 1.1, I guess, or 1.1
1.2, if you look on the right,
a couple versions of 1.2.
Yeah, no, there are 2 versions released this year.
Oh, yeah. Okay.
You can see on the right.
Oh, yeah, because I remembered, because I think we went over the, like, 1.2.0 pre-4 on the first version, or the first episode of this show, because we hadn't talked about it yet, but it wasn't actually that's this year. So so exciting stuff. Glad that that's out there. And and
we should probably go over some of the questions before we get too far in.
Feel free to pop any up that you find interesting there,
because there's someone, for one thing, because we went over the netcode episode, someone asked if you tried MPPM, whatever that means.
So MPPM is multiplayer play mode, and that's kind of the tool set where you can basically test with like multiple instances of the game just right within the editor. So I haven't used this. Supposedly this works with Dot's netcode projects as well. I had talked to somebody who had used like a kind of pre-release version of it a long time ago, and they said it was just like really slow and not quite there yet. So I haven't gotten a chance to test it out recently, but and again, like I was saying, I was just kind of running builds to do that testing basically.
Okay, and someone also asks, and this was asked a little earlier, since we were talking about system API query, is there any way to use that with an existing query that has been built with an entity query builder before? And the answer to that is currently no. And the question is whether we want that or not, because it's kind of, there are some cases where we would need to figure out an overlapping query, which is something that we actually did do for iJob entity. So if people just use iJob entity today, that will work, and they can like write out everything in a system in an iJob entity, and then they can pass in their own custom entity query to that. Something you can also do is you can use a system API entity query builder. Then get the query, and then you can do 2 entity array, loop over, and do something with those entities. I don't know what you would do in that point, but the nice thing about doing it that way is that you can often do entity manager operations because you already prefetched an array of entities, and then you loop over them. So therefore, you're not afraid of adding or removing any components to them because you're still referring to them, even though they might have changed archetypes along the way. Yeah, and the worst case you can do is if you were to like get component while you were looping, and that referred to an entity that you're going to loop over the next time around, and then didn't destroy entity on that. So now you're trying to loop into an already destroyed entity and getting a component on that, which, yeah, of course, that can be problematic.
Right.
But generally, there's the cases where you need a different entity query builder from a what you actually have as the system API query itself should be so low that iJob entity should be good enough for you, at least today. Yeah.
Cool. Sounds good to me. Anything else you wanted to hit before we move on?
That looks right. I don't think there's any more questions right now.
Sweet. Sounds good to me. Well, yeah, we'll move into our instruction sets. This is kind of the, we're going to do our little DOTS challenge recap. So yeah, once again, the challenge was to recreate the best performing version of Conway's Game of Life that you could. And so, yeah, I think it was a very fun and successful challenge. Let me go ahead and just like share my screen here. Just kind of showing the Discord here where, it was very active throughout the course of the challenge. A lot of people were sharing their progress and kind of like going in depth about talking a lot about the optimizations and things that they made and, funny bugs and stuff that they run into along the way. So let me just actually kind of go ahead and catch up because there's a couple things that I want to showcase from my project. So yeah, real quickly, I'm just going to go over what I did for the challenge, and then I'm going to go into a little bit about the kind of other people's submissions to the challenge. So I think we're getting close to... Yeah, here we go. So this is kind of the start of the challenge here. So when the challenge started, I was actually traveling. So I did kind of my initial implementation of this just while I was on the plane here.
Oh.
Yeah, I did some just kind of, basic grid spawning on the first flight here. And then, let's see, what else did I have going on here? Oh yeah, and then so after that, then, when I was in my hotel room, was watching the UFC while doing a little bit of programming on the Game of Life, and kind of got the basic implementation working. So you can see it all kind of simulating here. So the idea that I did for the basic implementation, and this is something that a lot of other people did as well, is they just had one entity equals like one kind of data entity, and then there was also another separate kind of rendering entity. And then each data entity had references to the neighboring entities, just using kind of like a dynamic buffer. So each entity kind of knew its current status, and then it also had a dynamic buffer to reference the entities surrounding that particular cell entity to see, if they're alive or dead, and then it kind of would buffer those for the next iteration to know that if on the next generation that it should be marked as alive or dead. So that was kind of like a pretty common pattern. And so, I just kind of did that, first implementation, just did stuff all on the main thread first. And then once I got the main thread stuff running, ended up moving over to the multi-threaded version. And then let me just kind of real quickly bring up, I think I had a little bit of things in the commit messages about my performance metrics here. So going back to the beginning. So 25 frames per second on the 512 by 512 grid, doing main thread. And then when I converted it over to multi-thread, then it was 115 frames per second on the 512 by 512 grid. Yeah. So again, yeah, that was just kind of like my first pass at the implementation. And then what I wanted to do as an optimization after that is still by using the one entity per cell, ended up doing what's this called? The Hilbert curve, kind of spawning here. So this is kind of basically what it looks like here is you kind of spawn them in this kind of like pattern, this kind of like cycling back on itself. And this is, again, still using the dynamic buffer. This is just kind of a different visualization where it's more of kind of like a color gradient of kind of like, yeah, you can see that it kind of starts in this lower corner here, and then it kind of, is
it's
kind
a
of curving
recursive
around.
pattern.
And it's a recursive pattern. And the idea with this is to basically optimize for data locality, so that when you do this, so first I was just kind of spawning them linearly. So I believe they went up first. So basically would spawn all these in this row, all these in the next row, or the next column rather, next column, and then just keep going along like that. Now, the potential issue that I saw with that is that, once you get to the point where you have so many entities stretched out that now, when you look at the entities above and below it, those entities are going to be within that same chunk. So those can be accessed very quickly because those are, already going to be in the cache and everything. However, if you're accessing the entities to the left and to the right, and then of course on the corners left and right, then those entities are going to be within another chunk than the one that you're in. So that would likely incur a cache miss or a random access where you're kind of going out to memory. Although maybe again, kind of going back to the concepts of hardware prefetching, maybe the computer can kind of recognize some of those patterns and know that I'm bringing in data from those kind of neighboring chunks. So again, what this was me trying to optimize is data locality, so that the physical positioning of these data entities we're all very close to each other. So now that you see, like if I look at, say, this entity and look at its neighboring entities, you can see that pretty much all these entities were spawned within like a pretty close proximity to each other. So very likely all these entities are going to be within the same chunk. So the idea was to kind of optimize for that, so that, my thinking was that the entities kind of surrounding this entity, it'd be a lot faster to access. So the interesting thing was, though, is that my performance actually ended up being quite a bit worse. So what I had kind of noticed is I kind of made a little basically tool to determine the what I call the hit rate of basically cells that are checking neighboring cells that live within the same chunk. Now, with the linear implementation, there's a hit rate of only 25%, which makes sense because you think of the entities within the same chunk are only the entities above and below. So that's 2 out of 8 neighbors, which comes out to 25%. So that math checks out. Now, with the Hilbert curve, I calculated a hit rate of 85%. So that basically means that 85% of the time, an entity is checking a neighboring entity living within the same chunk. And I was basically just able to use the what is it called, the entity storage info, to see, you know, what chunk I was in, and kind of compare the different chunks there. So yeah, with the linear implementation, do I say what speed that I was getting? So this, so the linear implementation, I was getting 120 frames per second. Well, here's with the Hilbert curve, I was getting 90 frames per second. So I was very confused by this. I think, you know, Phony kind of mentioned some things here that I think that are kind of the cause for it, is basically because, you know, when we're doing the linear implementation, we're just kind of going to a memory location and then just doing a, you know, straight offsets from that, which is, you know, a lot easier to do than saying, you know, going to, you know, multiple memory locations, even though in theory, those memory locations should all be in the cache. It probably is just a little bit simpler for the computer to just, you know, get those, you know, three
I think prefetching is
memory
going to get you
locations.
a lot of the way there. Like, it will probably prefetch for you in the linear case, whereas you pretty much stopped any change of it prefetching now.
Right. Yeah. Because it's just kind of it just kind of sees this as some weird pattern where I'm just like saying, oh, go to this.
Yeah.
Where, yeah, again, the hardware prefetcher is probably, you know, smart enough to say, oh, this guy is, you know, looking at these things all in this same row next to each other. And yeah.
Yeah, no, I mean, the interesting thing here is that Vulkan actually has or I think most GPU languages actually, but at least I very vividly remember having to specify in Vulkan, because you have to specify everything in Vulkan. This is the way that the texture should be stored, and it should be, and the default that you pick is actually the one where it's more tile-based, locality-wise, than just a linear array of pixels going through. So it actually uses something very similar in style to this, because it means that you can effectively go around it, and so you can more easily do like a sand implementation, like a classic sand falling implementation,
Nice,
or cellular automata with this, which this is
what we're doing.
exactly.
So yeah, that was definitely surprising to me, because again, it just goes to show you that, you know, you may have some assumptions about an optimization, and it really only takes testing it out and trying it in practice to see if that optimization is going to work or not. So yeah, I was very surprised with this myself. So yeah, that was, yeah, probably one of my biggest takeaways from just kind of doing this challenge by myself, because most of since the last time that I did it, I think someone had kind of mentioned doing the whole Hilbert curve thing, because again, my kind of assumption was that I was being performance limited by creating bigger and bigger grids to the point where, you know, entities that are above and below, or like side to side, are outside of the you know, current chunk that it's iterating on. So yeah, very interesting.
There's a chance you might still get performance out of having smaller grids where that's the case. I think the problem here is also the fact that it's everything that is part of the Hilbert curve. If you were to do just like a tile has linear, and then another tile has linear, then it's should be more easily able to do that. Fine, but are we gonna go into what other people are doing?
Yeah, we will in just a second. I just wanted to hit this. So I don't think that I think I just tested this multi-threaded, but my assumption would be that single-threaded would see the same performance differences. I don't think there would be any difference for multi-threading for this particular thing. Yeah. And then so the next thing that I did is basically what I have the project as right now, where I ended up kind of doing a more, you know, call it like a packed version, where I'm going to try and explain this as best as I can, and, you know, hopefully without losing everybody too much here. But basically, I used a unsigned long, which is a 64-bit integer, to basically store the alive state of 64 cells. So that basically made essentially an 8x8 grid, where I could basically have, cells be alive or dead. And actually, you know what? I'll just go ahead and play this here just to have it running in the background as I'm talking about this. But so that's kind of like the base building block is entities are stored in a unsigned long, again, a 64-bit integer, where cells are either marked alive or dead. And okay, there it goes. And then so then I had that stored in a dynamic buffer component, and then so one entity then had 16 elements of that dynamic buffer, and then so I would have several of these entities for depending on the size of the grid. So that's kind of how I ended up breaking it down. And then I think one thing that I kind of noticed is when I started doing a lot of these kind of like low level bit level operations like this, is that entities actually kind of started getting in the way a little bit just because of how I had set things up. Because like now I kind of have these like 3 layers of things, which in retrospect is probably not the best way that I should have set things up, but I was just kind of playing with some of the ECS tools in ways that I thought was interesting. So I'm kind of glad that I did it that way. But basically what happens is now when I have a 8x8 chunk of cells, I can simulate that on its own, no problem. But of course we want to expand the grid size. So we need to have, these 8x8 chunks basically kind of communicate with each other so that it knows, when cells, are on one edge of one 8x8 grid, they need to check, on the edge of the next one. Yeah. So what I ended up kind of having to do is now I needed to not only reference the other entity, but I had to reference the index in the dynamic buffer that kind of 8x8 chunk was on. So just ended up being kind of like a little bit of issues with things that I had to track around that. Which in the end is not really all that bad. Like it kind of makes sense, but kind of getting to that end point, there were definitely some hiccups along the way, and I had to do a lot of just kind of low level, bit level debugging. So a couple of tools that I just wanted to point out. Of course, I used the JetBrains Writer IDE. And then I had attached the debugger to the process here, and then was basically just kind of did that, classic John Carmack solution where, just put a breakpoint in and just step through things line by line and make sure that the, program is doing exactly what I think it should be doing. So I was able to kind of validate things and see where things go wrong, especially in certain edge cases. So that's something that was super helpful for me to do. And then I also kind of use this in tandem with this little application here. This looks horrible on this screen.
There's some scaling issues there.
Let me take a screenshot of this on the other screen and show you what this is all about. So this is a little program called SpeedCrunch. Learned about this tool from, we talked about him already, Casey Muratori. This probably is too small for it, but it's basically a calculator.
If you could zoom in, that would probably also help.
Well, yeah, I don't think I can zoom in on this application. I'll do this. We'll save this.
Just do Windows Shift S, which will, use the window snipping tool instead, which will actually let you zoom.
There we go. How about that?
Yeah, there we go.
Okay. So this is called SpeedCrunch. It's basically a very fast calculator. And then you can see at the bottom here, there is basically a kind of bit calculator. So what I could do is I could basically punch in the specific bits, because again, each bit maps to a cell. So if a bit was, say, if like the 0 bit was on, I could click the 0. If like the 7 bit was on, I could click the 7. And then basically I can do all this, and then it gives me what the unsigned long value should be. So this was kind of interesting. I did this for a couple things. One of them is just kind of my like initial testing, where what I could do here is inside the, I guess this would be in here. On this here, I had a starting value, and then by setting this starting value to this 394500, that would create a glider, and then I could like test with a glider, which if you're familiar with the Conway's Game of Life, there's these different kind of like patterns that you could create, and so glider is one of them that just kind of like goes across the screen. And so this is a good way that I was able to test the Game of Life to make sure that as I'm going across those cell boundaries, that things are simulating appropriately. So I was able to kind of again use this speed crunch program to kind of craft these to make sure I have the correct starting value where all the bits are in the correct location. And then again, as I was going through and debugging, I was able to see like, okay, so this next bit should be on. Let me go ahead and, select this, and then I could, verify that the, unsigned long value is correct after every iteration. So this was super helpful for me to use as well. But it disappeared. Oh, I guess it disappeared when I opened the subscene here. But I am overall decently happy with my implementation. I do have a bit of a memory leak here, which I haven't gotten a chance to track down. As you can see, that it's just kind of slowly going up and up and up. I still am using a pretty naive rendering solution. It's still just a single quad entity per data cell. So, not necessarily the most efficient, and then I'm just setting the color of them using the material property color overrides there. As far as performance goes, I believe I was able to simulate a 1024 by 1024 grid at around whatever this was running at. 30. I'm doing like some screen sharing and stuff, so I think it was a little bit more, maybe 45-ish for a 1024 by 1024 grid. So pretty decent performance numbers, I would say. But yeah, that's kind of like basically my main implementation. There are of course things that I would want to do differently and try otherwise, but I think this is kind of a good enough base to work off of for now, to maybe test some things off of later.
Yeah.
But do you have any thoughts on my implementation before we move on to some of the other things?
I mean, I definitely recognize that I would have done things very differently than you would. Because I think my main approach would probably have been to start with a binary array, which is something that is in our native collection package. That lets you basically just have one big array of bit data, and it will obviously always use like a byte underneath, so it will have to allocate a byte every time, but it does allow you to have n amount of bits, and then you can assign them and you can check against them, and I would immediately start using that as my grid cell. So all 1024 times 1024 would already be in the bit array. Just one long array, and then once I have that, I will then loop over. I would start by maybe having an ijob4, and in that ijob4, from an index calculating which xy value you are at is very easy.
Right.
Because it's as simple as doing a modulo and a division operation that will get you the xy value, and then you can just plus, minus, and that will then you will then be able to calculate that back to the index very quickly, so you get all the surrounding cells. And so you can do the simulation itself just in the binary array. And then once you have done the simulation, then you need to figure out, how do I do the visualization? Well, okay, one way to do that is either I'm gonna have an entity represent every one of them, and then I'm just gonna loop over again.
Yeah.
I'm just gonna have a native array. Basically, when you instantiate, when you go to Entity Manager instantiate, you can actually pass in an array. Say you were to pass in an array that is the size of the binary array, it will then also make sure that array you now have actually contains every single entity. And so now your second pass that you're looping over could simply loop over every single like index, and then it will assign that. And you can even do stuff on top of that. You can make sure that it's already archetype based, so you can loop over every archetype. And then realize, hey, maybe I just need to have an entity represent 8 bits at once, or maybe even more. That's probably the approach I would have taken, instead of trying to make the algorithm more complicated with a Hilbert curve and start making, this entity represents. I think I would focus more not on the simulation. The simulation is very easy to do with just a binary array, and I wouldn't recommend anything.
So don't even really use entities for that portion almost.
Exactly, because that overcomplicates it. That should either happen there, or I guess technically it could also happen on a GPU. But for the point of this project, it should still happen on the CPU. But having it happen on the CPU should really just be a binary array. There shouldn't be more to it, because that overcomplicates it. That's how I would have done it. I actually did do Game of Life like in 2016. It was one of my first games. I just remembered like during the stream that one of my very first games was at a camp called Game Development Camp, and we made this game where the point was to that there would be a display grid that basically like a casino deck that with like poker chips on it, and you would have to guess what the how to make that pattern. So basically, you had to like put down pogo. What are they called? Like the discs that you put down in poker.
Poker chips.
Yeah, poker chips. So you had to put down poker chips, and then press a next button. And when you press the next button, it had to match up with the pattern that was already drawn. So you had to sort of guess how to make it result in the next iteration. Which was a fun game. I might be able to show it if I get it working during when we show off everyone else's stuff.
Cool.
So I apparently have made it before, but it was way more inefficient. Like imagine it was game objects, and imagine that every game object had to know about every other game object, and it was pointing. This is like Kid Daniel.
Yeah, no, but your kind of initial thoughts on how you would go about implementing it with the bit array and everything, that seems, like a nice solution. Again, I kind of just wanted to do some more experimenting with more of the, ECS kind of based features of the language and everything like that, which again, like I mentioned, I kind of ran into some challenges from those, and probably would have done it differently. If I was kind of optimizing just for performance. But again, I think I learned a lot, and I was very happy to kind of do this here. So anyways, we can go ahead and get into some of our projects here. You can see that we had 21 entries from the community here. And so what I asked everybody to do for the submission was to basically include an executable so you can, simulate the project on your machine. And I tested out pretty much all of these, I think all of them about on my machine, just to see kind of how they were doing. And also had everybody create like a write-up about kind of their performance strategies, things they learned along the way, etc. And that was super interesting. I read through all of those, and there was definitely a lot of things that I had learned, and kind of it was cool to see people's kind of interesting solutions on things. So just want to take a little bit of time to kind of go through some of these submissions, highlight some cool things and all that. So real quick,
21 entries. Holy shit.
Yeah, I'm super excited. Yeah, Yeah, and people did like a lot of kind of different things. Like there were some people actually, I mean, we'll get into all this here in a sec, but yeah, I mean, I just wanted to, congratulate everybody who did end up putting a submission in. Because yeah, this is it's an interesting project, and I think everyone did a good job about getting a good working Game of Life in. I know there were some people who had also been working on the project that they didn't get a chance to submit. So, but yeah, still just wanted to congratulate you all for participating in this first Dots challenge. Hope you enjoyed it, and of course, we're going to be doing some more kind of game jams and challenges in the future. Because yeah, I was super happy with this one so far. Not gonna lie, it's kind of addicting to squeeze out performance and also an awesome learning experience. Nice, that's exactly what I wanted this to be. So, okay, so real quickly, do just want to call out Brain Shack, who was the first person to submit, which I believe
No
they
image.
submitted. Yeah, no image, but yeah, I believe they submitted like right on the like Monday after the first weekend. Oh wait, and it
Oh,
switched over to the tab here, but yeah, and then they had kind of the performance strategy inside the repository here. And then also wanted to point out who is it? This one here, Pup Spectre. Was the final submission of the challenge 1 minute and 54 seconds before the deadline. So putting it
Damn.
right up towards the edge. So shout out.
oh, he's in chat.
Hey, nice.
Right at the deadline.
Yeah, that's awesome. So, and then, yeah, also wanted to call out TJ2G. Where is that project here? Yep. So, TJ2G submitted a project here, as well as this person, Alessandro Brizio. They had both mentioned in their final write-up that this was the first full ECS project that they had created. So, just, yeah, wanted to congratulate them on that, coming in with little to no ECS experience and being able to create a full project, which is super cool to see. I don't remember the, I think it was on, TJ's project. They said that they had gotten, like a 1000 by 1000, 1000 by 1000 grid at 60 frames per second, which, again, your first ever ECS project, and you're able to simulate 1 million individual cells. I think that's pretty cool. So yeah, there's just a couple quick little shout outs to some random things there. And then yeah, going into kind of some of the more performance oriented things. So the kind of overall performance crown for kind of a non-ECS version, is it this one? No. That was another one that I wanted to show, but yeah, this one from Lask3802. This one is, yeah, absolutely the highest performing one. So they did a couple different implementations. So they have a kind of one implementation that uses mostly jobs, burst, and mono behaviors on a static sized grid. And they had like even multiple different algorithms and things to that they had tried. And by the way, I would recommend, going through a bunch of these readmes. Like this one is kind of one of the more in-depth ones where they kind of went into a bunch of the different solutions that they played around with. So there's a lot of good and interesting information in there. But yeah, so on my computer, which I think was a little bit stronger than the computer the original submitter was testing on, I was able to get a grid size of 32,768 by 32,768 running at 30 frames per second. So that is 1 billion individual cells all being rendered on my screen, simulating at 30 frames per second, which
That's
insane.
That's pretty
Insane. So yeah, that was totally blew me away. They use this LIAR algorithm, which I believe it stands for life in a register. And they linked off to it here, and they basically, from what I understand, they used kind of the similar structure to me, where it was kind of like individual, like 8x8 cells, maybe stored in like a U-long or something of that nature.
Yeah.
And then by using this algorithm, they're able to easily and quickly simulate the middle 36 cells, and then you only really need to account for the 28 cells on the perimeter. So you check the ones on the inside as well as the ones in the neighboring kind of 8x8 grids. So yeah, now that they linked off to this, I kind of want to go back and put that in my own project and see if I can get any performance boosts from how I have things set up here. But they also talk about doing some burst optimizations, and so rendering. So it looks like they were using like some compute shaders here for actually doing the rendering. So yeah, again, the crazy performance one was not using any ECS. It was just jobs, burst, and mono behaviors. So still using dots, but they did do an ECS implementation of it as well. The ECS implementation, again, completely still kicks the teeth in of my implementation. Running on my computer, I was able to do a grid size of 8192 by 8192 at 40 frames per second, which is still very, very solid. That's a lot of entities. But yeah, I would recommend, if you want to learn about some more of these algorithms and optimizations, to check this one out here. The other kind of high performing one that I noticed was from ITR. I know ITR was kind of streaming development throughout it. And then, I think they put it on, the game page here. Kind of going over, some of their performance metrics and what they did. Again, they also have multiple algorithms. They talked about the different algorithms they used. I think it was cool. They tried to use like a quad tree type simulation to see if they could kind of optimize some of the component lookups. That ended up not being as performant as doing some kind of hash mapping algorithms, which they'd shown. And again, pretty in-depth write-up about the whole development process and all. So this one, a pure ECS solution. This takes the performance crown for the pure ECS based solution. So the 8192 by 8192 grid, I was able to run that at 60 frames per second on my machine. And then doubling that to the 16,384 by 16,384, I was getting about 15 frames per second. So still, pretty solid numbers there. This also did not allocate a whole lot of memory at all. I think even on the 16384 grid, it was still at like less than a gigabyte of memory allocated on that, which was super cool. Would highly recommend kind of reading through that one if you want to learn about some of the more kind of crazy performance optimizations to squeeze out those very high numbers. Next one that I wanted to call out was from LiJam. So LiJam wanted to call this one out because they did put up a video explaining their whole kind of solution and what they did here. I haven't watched through the whole video yet, but they kind of explain through the game of life and what they do by making a high performance Conway's game of life without using Conway's or without using compute shaders. So this one was, pretty good one as well. So this is a 4,000 by 4,000 grid at 60 frames, 6,000 by 6,000 at 30 frames. And this machine is fairly comparable to mine. So I think my performance numbers were pretty similar, maybe just a little bit better than this, but still really solid numbers. Oh, this one was super cool because they had a really interesting solution to the alive versus dead cells. So most of them, Like what I did and a bunch of the other ones that I saw, they use like a bit to represent it being on or off. But they actually used a full byte to represent it being on or off. So they basically had the 0 byte as it being a dead cell, and then, or no, so they had the 0 byte as an alive cell, and then 0xFF, which is basically the maximum value for a byte to represent a dead cell. Now, what they did is they basically just directly loaded this byte into the alpha
Load
channel
raw
of a
texture.
shader. Exactly. So then it basically sets the transparency on that.
Well, it
for
doesn't even have to be a
turn it
shader,
on
by the
or
way.
off.
That very method
Well,
means you don't. It doesn't have to be a shader.
Yeah.
You quite literally can
I
just use a
misspoke.
quote at
Yeah.
that point. Yeah.
Yeah.
Because when you use load raw texture data, there's an extra argument that you have to add, whether it's going to be in the format of RGBA 32 bits per, or if it's going to be just one singular alpha byte per pixel.
Makes sense. But yeah.
But that's
and
awesome.
then,
That's a good way to do that. Just
yeah,
have a,
I thought it was a super clever solution because it's like, yeah, you have all the data and then you just put it right to this load raw texture data.
yeah, and it's already going to be a native array that you pass into load raw texture data.
Yeah. And then, so yeah, again, check out that submission from Ligejam. They did make a video kind of going to that. So I definitely do want to watch that when I have a moment here. Okay. And then, so just kind of going over some of the like kind of common patterns that I saw as I was kind of like reading through these. Again, a pretty common pattern was just kind of the simple implementation that I kind of mentioned, where one entity maps to one cell, and then you store the neighbors in a dynamic buffer, just to kind of look them up that way. Another kind of common thing that I saw from a bunch of people was doing essentially like a wraparound grid. So when you're kind of like at the edge of the grid, you're looking at cells on the other side of the grid, and that way you don't have to consider the literal edge cases where you're on the edge of the grid. Yeah, funny. Or you're on the edge of the grid and you ignore those off to the side. So yeah, it's I guess it could be considered as a little bit of an optimization, because you don't have to do some extra if checks or whatever, because everyone basically always has the appropriate neighbors that they need. Yeah, a bunch of people are also doing, if you're doing the one render entity per cell, they were using the material property override to just kind of set the colors, which is basically what I was doing as well. Some interesting tricks that some people had put in is like skipping some rendering frames. So basically you would kind of like simulate the game of life multiple times per render frame. So that way you could kind of simulate the simulation faster, because you don't have to wait for rendering. You could say simulate 4 generations on the data side and then just display that once on the entity side. So I did see a couple of people doing that. One person had a kind of interesting solution where each entity mapped to a basically chunk of 100 by 100 cells, so that at that size of data, then it's basically one entity per ECS chunk. So they basically just filled up one chunk with one entity, and all the associated data on that. Then let's see. Oh, and then yes, I think this is the same person. Batched the game of life to run. This might have been somebody else, but they basically batched the game of life to run on one section of the grid at a time. So you don't kind of have that. Again, you can't be rendering it every single frame. But if you have very large grids, you can kind of break it up into sections so that you're only kind of simulating one large section per, per Unity frame. And then once, all those have been completed, then you just render that out. so you can, yeah, I guess simulate it a lot quicker, I guess. Yeah, a couple of people did a similar solution to what I had, where I had, basically the 8x8 cells stored in a U-long, which they were able to use actually some. I didn't use any like crazy clever bit operations for this. This is just, which is something that I would want to kind of optimize for a little bit more if I had some time. But I guess they were able to use kind of some bit operations to very quickly calculate the next stage in that 8x8, which I guess reduced the need for a lot of if statements and for loops. And my code definitely has a whole lot of if statements and for loops and, checking for specific cases. And I think that kind of leads to a lot of the inefficiencies with my current implementation. So again, it would be kind of go back to figure out some ways that I could kind of reduce a lot of that by using some just, regular bit operations across all that. We've kind of already talked a little bit about rendering, but, some people were saying that they were, using each cell to to write directly to a pixel and a texture, so that, if the cell was on, they would, write to that versus not. Some people use the like batch render grouping. I see one person that used the built-in render pipeline with GPU instancing and the draw mesh instance indirect. So yeah, it was kind of interesting to see, how people, wanted to render all these things, because that, rendering, it does kind of very quickly become a bottleneck. Once you kind of optimize, do some more or less basic CPU optimizations, and you can really scale your grid up. Well, now you have to deal with the rendering. So that was something that a lot of people started doing, is kind of doing some rendering optimizations there. Couple unique submissions. So this one from Madam, I think, is that?
Yeah, I so wanted to ask about that one, because I noticed it was 3D.
Yeah. So this one is 3D. I thought this one was super cool because, so they actually used cubes per the entities. And so, you can kind of see that how the grid kind of plays out here. And so, what they were doing for, alive entities is they're basically just moving the Y position up and down. I'm not sure if this is like a separate plane, or if these are just like the tops of all the other cubes. Unfortunately, there's not really a lot of contrast, so it just kind of looks like the Minecraft desert, where it's just all that one single color.
Yeah, it should have some Darude in the background playing Sandstorm. Or especially with the gliders, like moving around.
Yeah. Sync it up to the music a little bit. That's a great idea. A little 3D visualizer there. But
put it on TikTok.
But yeah, so I don't know what else I wanted to say about this one, but yeah, the 1 million entities, I was able to run this on my machine without too much trouble here. And so yeah, it was cool to see kind of like a unique submission where someone was doing stuff with some 3D. Also, this one from Ani Anko, they were doing some interesting stuff as well. Let me see. I don't really know how much I can. It's kind of a little bit difficult to tell with this one right here, but they also did kind of a 3D type solution where in this case the cells are cubes, and then you can use the little kind of joystick in the lower right corner to give you like a little bit of perspective to kind of get a different perspective on this one. This was also a super interesting solution because they kind of like added they kind of like gamified the game of life. So you can like try to get a high score, and basically the way that a simulation ends is once you reach a state of homeostasis where the simulation is just kind of looping over itself, is just kind of repeating. There's no additional things being added in. So again, kind of a unique solution, just kind of different than the standard game of life there. And then, yeah, as we're getting to the end, I just kind of wanted to bring up a couple of issues that seem to be common issues across a bunch of these solutions here. One thing that I had kind of particularly seen a lot of in the Discord is that people were having some issues building the project. Like they went to build and the build failed, or if they had successfully created a build, it would crash right away. Of course, one I think common culprit for that was the whole particular entities, specifically related to like singleton entities, weren't quite loaded at the beginning of the of when the game runs, and then the system is kind of like running expecting to find that singleton entity and then just hard crashing the machine. And there were some other things. One thing that I had noticed, and maybe I'll actually end up talking to you about this after a little bit. I was having some kind of issues building with IL2 CPP, and it was kind of like pointing to some like type handles with a bunch of just like random string of characters. So I wasn't able to. It's kind of difficult for me to kind of track it down.
I think I think it's related to a bug report I've seen internally.
Okay.
Maybe I'll have a chat with you after. Maybe looking at it.
Yeah. And then, but I was able to build with mono and build that. And then, someone actually kind of brings up a related question here. Does IL2CPP yield performance benefits for DOTS projects that use Burst? My understanding is yes. Do you have any additional?
Yeah. I mean,
Cool.
Generally, IL2CPP should be a little faster.
Yeah.
Than mono.
Makes sense.
But that's also just mono being slow and bad.
Fair. But yeah, the mono performance ended up being like, only marginally better than my editor performance. So, most of the performance numbers that I was testing with, just in the editor was fine. But, again, did see some people having a bunch of issues with building and couldn't get the project to build. But, and then debugging was also kind of another pain point for some people. I think some people were having issues getting a debugger connected and kind of stepping through some things. And, sometimes when they were like kind of making some code changes that the debugger didn't quite synchronize correctly. And this is something that I had kind of been noticing as well. Like sometimes I would kind of end up needing to restart my IDE every once in a while when things would just kind of like get out of sync, as I was just kind of like stepping through things. I think, some people had just kind of gave up on it and just straight up did debug.log for a bunch of their debugging, which...
I mean, debug.log works for a bunch of things.
It works. But yeah, I think for me, like, especially when I was doing all those like low level bit operations, doing debug.log for everything like that would have been very, very annoying. Luckily I was still able to use the debugging tools and,
I mean, in the recent update, we did fix something with breakpoints, because we kind of have to manually.
Well, there you go.
It's probably related to what Christian is talking about here.
Yeah.
So if he tries the new version, maybe he doesn't have that problem anymore. Because the thing is, when we do source generation for breakpoints to match up with what we are we are changing the method that you have. So in your own update, if you write a system API function where you implement that function with like a copied version that has a few changes in it, and then we put that in, we also have to specify in that source generated code. When you put a breakpoint, you're putting it at code that technically doesn't run. So what line should it actually point to IL-wise? Because the generated code that we've generated is it's a totally different method. And that's the code that is actually being run, the totally different method. So you should still be able to put a breakpoint down in your code, in the code that you actually think is running, and it, magically gets put over to the actual point where the breakpoint actually lives, which is in the other file that we generated.
Yeah. It is kind of cool that it when it works pretty well. That it's like the code that you wrote is different than the code that's running, but you can still, kind of
Debug it.
step through the debugger through the code that you wrote,
Yeah.
and you can inspect all the values and
yeah. No, it's good and bad. It's because it is a fucking nightmare to get right, and it's also
I'm sure.
It's questionable how nice it is actually for debugging, because you're not actually stepping through the code that is actually running. But
I'll say
nice.
it was helpful enough for me to figure out the issues that I was having.
That's awesome.
So,
And
yeah.
that's and I mean it also is similar to what people expect. They expect to be able to put breakpoints in their code that they wrote
Yes, yeah,
and step through it, and that's what it does.
yeah.
It's just lucky that it sometimes gets off tracked a little, and so we have to do some bug fixes. But obviously we do them as fast as we notice them.
Yeah, no, I know you guys rely heavily on that source generation, of course, and it seems like, pretty much every time that there's a ECS update, you'll see a couple entries in there about, fix some weird edge case with source generation, and it's like, I'm sure that's, like you say, a fucking nightmare.
Sure, it's not PG. There you
go. But yeah, so I mean that is our kind of a overview of the bunch of the submissions and kind of highlights and things that I learned. Again, I would recommend, if you're interested in a lot of these optimizations, go through and read these. I think everyone did a really good job about putting in some good information during in their, along with their submissions. So yeah, Dan, do you have any kind of overall thoughts? Anything else that you wanted to bring up on the DOTS Community Challenge here?
No, I'm excited for the next one. This was fun. It's cool to see. And also just the fact that we got 21 submissions, that's wild.
Yeah, I'm super happy with that. So yeah, shout out to everybody who participated and joined along, hang out in the Discord and everything like that. And we'll have some more info on the next challenge or game jam soon enough. I think I kind of want to maybe get a little bit of information from the community and see what people kind of most want to do for the next one, because of course we have some ideas of things that we want to do, but just kind of see what people in the community are interested in kind of doing as well. So anyways, with that that kind of wraps up the portion of the show where we're talking a little bit about the DOTS challenge. If anybody has any questions, I'm not sure, we were just kind of like answering some things along the way, but feel free to kind of put those in now. But otherwise, I think we just go ahead and start to close out the show as we go into our dynamic allocation, where we have kind of some fun things to share with the community. So Danny, I will have this prepared on screen here already for you, so feel free to chat about what you wanted to share here.
No, the thing I want to share today is simply just how awesome KKit assets are, K. Lausberg. I don't even know if I'm saying his name right, but pretty much every single project that I have made for this channel either uses my own assets or his assets, specifically because they are CC0 licensed, and it means that I can put them in my project and they are freely available to use, and they all look brilliant. They're beautiful assets and they are free to use. And he even provides extensions to those assets if you're willing to pay a little more and support him, which is a good thing to do because this is awesome. Many people already use Kenny's assets, and K. Lausberg or KKit is very similar to that. And they're really nice assets, and you likely will see more of me using those assets.
They're good assets, and K's a great dude. I've met him at a couple events, and
same. I mean, we all met at Unite.
That's right. Yeah. He was out there for that. Cool.
So I can definitely recommend people use those assets. They are awesome.
Yeah. Do you have a favorite pack in particular, or it's just kind of like whatever fits the project?
It's definitely whatever fits the project, but the prototype bits one is definitely one of my favorite ones, just because it's a good start project to use. I want to quickly test out this platformer or this shooty thing I'm doing. this little action thing. Then it has like small coins and a little character, etc. There's also like an animated character in there that has a couple of good starting animations and animations in general. And then he has made sure that all the animations that he has works with all the characters he has, so you can just like retarget them for every single character, which is very nice. It's makes it very easy to use.
Absolutely. Well, I will go ahead and post the link in the chat there. By the way, speaking of hanging out with people at events, Chad Franklin, I was just hanging out with him at GDC the other day. So shout out. Glad to see you in here. Yeah, so anyways, we can go ahead and move on over to my dynamic allocation. So we'll see how well this shows up on here. I've
actually seen this. I saw this post and I think it was Reddit.
Yeah, I think I came across this in our Discord. Someone had posted this in here. So yeah, you probably can't see what this is right now, but this is the Cities Skylines ECS Explorer. So if we zoom in here, you can see that basically these are all the like different systems in the game, and they have kind of like all these like connections to each other. I have no idea.
Like, do they have the source available, or did they literally go and IL?
So I believe if I was kind of digging around, I believe if you go to this person's GitHub, they have the thing that they used to make it with. I can't remember exactly. I haven't tried it on any of my projects or anything like that. But yeah, you can say click on one of these nodes, and this shows the goodness. I don't want that to be highlighted. Is that
it even shows the properties related to it? Oh, that's...
Yeah. So yeah, you click on say one of these systems, and then you can see like properties, and then systems used by. I guess is this like systems that reference that system? Do you think?
I probably dependencies. So when you do state the dependency.
Yeah.
Probably which dependencies are on that system.
Gotcha. So yeah, this is basically I'm guessing the arrows are saying basically like this system depends on this system, right?
Yeah, I would assume so.
Yeah, and so you can kind of go through here and see systems used by, and then
there we have a simple example. So transform frame system is
game serialization.
Maybe it's the system grouping. So the transform frame system runs inside of the simulation system. Maybe.
Oh, okay. Yeah. So this is game system, simulation system. I wish there was like a little bit. Let me just see if I can go to their GitHub here.
I mean, the fact that they're able to visualize this is really interesting.
How did I find this before? All right, so here's this person's GitHub.
That's a beautiful dog.
Right? So, yeah, I think it's this ECS Explorer. So this project is an interactive explorer of ECS relevant parts of Cities Skylines 2 codebase. Currently, it supports extracting the following details from source code. So systems. What systems each system reference? What systems reference this systems? What components the systems uses? Okay. So I think it is not dependencies, but it is one system referencing another system.
What does it mean that one system references another system? Because from what I can tell from looking at the graph earlier, it definitely just looks like it's updating group and update after before type stuff.
I think this is more along the lines of when you do like system API.get system kind of thing, and you get like a reference to that other system.
I don't know. I don't feel like that. Because go back to the graph. if you look at the one you currently selected, which is a game simulation system, it says uses systems, and then which systems that
Okay.
it currently
Yeah.
uses.
Okay. Update system. Yeah.
Yeah. So that's probably what it has.
So update system has.
Yeah, systems used by the update system.
Well, maybe we don't know what any of this means, but it is cool to
Oh,
look
is
at.
the transform system group in there? Let's find the transform system group.
Here, maybe we can do a search for this.
Because
Transform.
let's look at something that we know what is.
To
Or the in command buffer. Maybe they have one of our command buffer entity command buffer systems.
and sim. Nope.
Entity command buffer system. Maybe search that name.
Nothing for entity command.
I'm annoyed. I feel like I would have to dig down into it. I this is cool to me. I just don't understand what it actually means because the problematic bit here is that it would almost have to run the code in order to figure out the dependencies, the actual dependencies. And the only real thing that it would be able to, from like a simple decompile at the very least, I would assume, is to figure out stuff like the attributes. So update in this group, update after, so on. It might also be able to tell some of the, like, it can definitely tell the source code, like from a, it has a get components lookup inside of it that references this other thing. The problem is it very quickly gets complicated on what system then, like how would you then figure out the system dependencies from that?
Right.
So I don't think it can do
I think
much
at the very least, it is interesting to see, the massive number of systems that this game has, and
yes,
the fact that they are tied in many ways here. So I'll go ahead and drop this in the chat as well for people to play around with, and maybe they can figure out.
It kind of also
means.
must visualize in a way like a hot path, like the one that you can see that has like a lot of connections to it. Surely must be a hot path
you can kind of It is interesting having this data visualization because you can clearly see like a lot of things have connections here. You can have that like green, and as you get closer, see more of these
like
here. So this is the game simulation.
Everything touches the game
system.
simulation system.
And then a lot of things also do the game simulation city system, and then the city statistics system, city configuration system. So again, this is the game Cities Skylines 2. This was made with Unity ECS, and it is interesting that we can kind of see all their systems and how they're all intertwined and connected to everything. So it is a cool little thing.
Imagine having to worry about execution order.
Yeah.
Yeah.
No kidding.
Yeah. No. Okay. Yeah.
Yeah. All right. Any other final thoughts on that?
No.
Sounds good to me. All right. Well, with that, we'll go ahead and start closing out our show here. So thank you, everybody, for joining us here today. Real quickly, I do just want to thank our Patreons for your support over on patreon.com/turbomakesgames. Again, you can go over there. I have a couple of bonus videos. I just put up one on my GDC kind of vlog recap where I'm showing a bunch of pictures and videos throughout the week and just talking about my experience overall. That one's available for all Patreon supporters. And then people at the L1 cash tier and above, they do get access to my behind the scenes video that I just put up where I'm going over the programs and cool little tools that I use on my machine. And then also I'm going to be recording a Q&A video this week. So if you're at that level, feel free to add some questions to that thread over on Patreon. And then do just want to thank our Patreon supporters over at the CPU Register tier, which is our highest level of support. So thank you to eCool for your support over there. Very much appreciate it. So with that, we can go ahead and just close out the show here. Danny, you got any final closing remarks for us before we head out?
Sadly not. Sadly not. But it's fun seeing all these projects.
Yeah, I was very happy to go through all these projects here. And yeah, I definitely did learn a lot from reading through all the submissions and everything. And I just want to go back to my game of life and start adding some more things to it already. So yeah.
Yeah, no, I wish I had finished my project out. Like I started working on it, and I did some really cool shit. And
Yeah.
I will maybe show that sometime when we have some further challenges.
Yeah, I was gonna say you had a really interesting take on the solution, and yeah, I think yeah, like you kind of hint at, maybe another challenge in the future could kind of use some of the things that you had started experimenting with.
Yes, and they also happen to use KKit assets.
Ooh. All right, then, everybody. Thank you so much for joining us here today, and we'll wrap up episode 10 of the Hot Pass Show. We'll be back here next week. It'll be me and you, Danny, and so yeah, looking forward to it. See you later, everybody.
See ya.